Welcome back to NB Global Gyan. How can a small force lift a heavy load? Mastering the principles of simple machines answers that question and guarantees marks in your next exam. Archimedes first defined the physical laws of the lever. He proved a rigid bar resting on a pivot multiplies force through specific geometry. This diagram shows a lever's three critical points: effort point, priyas bindu, where force is applied; fulcrum, alam bindu, the pivot, and load point. As highlighted, a lever's efficiency, iski dakshta, is always less than 100% due to friction. Identifying these 3 points correctly lets you calculate mechanical advantage and solve any lever-based physics problem. For exams, use the FLE trick to classify levers. The letter in the middle tells you the class. F is class 1, L is class 2, and E is class 3. Take a pair of scissors, kainchi. Because the pivot, or fulcrum, sits between the handles and the blades, F is in the middle. This makes it a class 1 lever. In a lemon squeezer, nimbu nichodne ki machine, the lemon is the load, and it sits in the middle between the pivot and the handles. L is in the middle, so it is class 2. Finally, look at tweezers or the human arm. Chimta ya manushya ka haath. The squeezing effort is applied in the middle of the tool. E is in the center, making these class 3 levers. Now try it yourself. Pause the video and look at this wheelbarrow. Ek pahiya kooda gaadi. Use the FLE trick and comment your answer below. The load is in the middle, making it class 2. This FLE mental model removes the need to memorize long lists of tools, allowing you to categorize any object instantly during an exam. Mechanical advantage, yantrik labh, is calculated by dividing the load by the effort. अगर भार ज़्यादा है और आयास कम लग रहा है तो यांत्रिक लाभ 1 से बड़ा होगा. There are rigid rules for each class. Because the effort arm is always longer in a class 2 lever, its mechanical advantage is always greater than 1. For class 3, it is always less than 1. The moment of couple, bal yugma, occurs when two equal and opposite forces act on the same axis. We see this in action whenever we turn a car's steering wheel. The center of mass, dravyaman kendra, is the point where an object balances. For stability, this point must stay within the object's base. This is why a person climbing a mountain, parvat par charta vyakti, leans forward to keep their center of mass over their feet. The Leaning Tower of Pisa doesn't fall because its center of gravity still points directly down into its foundation. If that line shifted outside the base, the tower would collapse. Understanding these physical limits, leverage ratios, and mass distribution is what separates those who memorize formulas from those who truly understand physics. Review this framework. It combines the FLE trick, the mechanical advantage rules, and the center of mass stability rule into one mental snapshot for your revision. Internalizing these specific points ensures you can accurately answer any question on levers or simple machines in a competitive exam environment. दोस्तों, ऐसे ही बेहतरीन point-to-point animated concepts के साथ next video पाने के लिए NB Global Gyan channel को अभी subscribe करें और bell icon दबाना ना भूलें. Success in exams comes from using the right mental tools to simplify complex problems. We will see you in the next lesson.